Hi, ladies and gentlemen. Root Beer here, looking at question 24 on the 2006 Fermat paper. Okay, so this is the second last question of the contest, and it should be a challenging one. 8 and 25, they're usually the ones that take me a little while. So I've got my pen. Hopefully you've got your pencil ready. Let's take a look. If a and b are positive integers, such that 1 over a plus 1 over 2a plus 1 over 3a is equal to 1 over b squared minus b, then the smallest possible value of a plus b is. So we've got some options here. Nothing about these answers is immediately jumping out at me. That's okay. I also know I have one equation, but two unknowns. It's unlikely I'm going to solve for a and b. Now, I do have an extra piece of information that they have to be positive integers. But it's unlikely, I think, that I'll say, oh, a's got to be this, b's got to be this. It's more likely there'll be a range. Now, they're asking me for a plus b, so I might not need to figure out what a is or what b is. As long as I can manipulate the equation they gave me and get an a plus b equals 10 or 50 out of it, I don't actually need to know what a and b are. They're also saying the smallest possible value, so I'm not quite sure how we're going to approach that. But let's copy down this equation. Now, the first thing I see is I've got a bunch of fractions. I don't want a bunch of fractions. So what I'm going to do is I'm going to multiply everything by I'll say 6a, because I want to get rid of these halves and thirds to get no fractions anywhere. 6a b squared minus 2b. So that'll be 6b squared minus 2b plus 3b squared minus 2b plus 2b squared minus 2b, and that's all going to be equal to 6a. So we can 6 plus 3 plus 2 is 11b squared, and then minus 22b is equal to 6a. Well, I'm going to, the call of the quadratic is actually no, we'll leave it as 6a. Now, this is 11 times b minus 2 is equal to 6a. I was going to rearrange and solve the quadratic of b in terms of a, but hold on for a moment. These have to be integers. So 11 divides 6a, but 11's prime, so 11 has to divide a because it doesn't divide 6. Interesting. So now the smallest value for a, it would be 11. And we know that we've got 6 here, so 2 divides b minus 2b. So either 2 divides b or 2 divides b minus 2. I can't make the same argument with 6, but I do have a factor of 2 over here. But either way, these two are equivalent. If b is even, then b minus 2 is even. So we know that b is divisible by 2. And now we also know 3 divides this side. 3 can't divide the 11, so 3 divides either b or b minus 2. So we've got some possibilities here. Where to go from here? Well, let's a being 11 seems pretty darn important. So I'm going to do 11 b minus 2. I'm just going to let a be 11. If I look at the answers that we've got here, by the way, a has to be at least 11, so that rules out 6, 8, and 10. It's either going to be 50 or 96, which makes me think a is not just going to be 11. It's going to be a bit more. But the point is, a and b are going to be smaller numbers. They're positive integers. So we'll try a is 11. And so that'll be 66. So b times b minus 2 is equal to 6. Now this isn't really going to work out for us. B's got to be even, so this is going to be 4 times 2. No, that's not going to work. 6 times 4. No, that's not going to work. We're not going to solve this. So we've got equality here. So if the answer were 50, if we can rule out 50, we know the answer's got to be 96. So if the answer were 50, we could try A is 11, or 22, or 33, or 44. 55 would be too big, because positive plus another positive would be bigger than 50. So I know I can see pretty quickly 11's not going to work. Let's try 33. We'll try 22. We'll try 22. So I can just divide by 11 and say, so let A be 11 times k, so then B times B minus 2 is 6k. Actually, this isn't so bad. Maybe we'll just do a quadratic here. So B is negative B plus or minus. I know I just said B is negative B, but I'm quadratic formula in my head. 4, so B squared minus 4AC all over 2A. So this is going to be 1 plus or minus. I can take out the factors of 4. So there's 1 plus or minus 1 plus 6k. And I need B to be an integer, so 1 plus 6k has got to be equal to a square. So, and this is true whether or not we're looking for 50 or not. So let's just take a look at values for k. In fact, we'll go over to the next page. We'll make a little chart. So k can be 1, 2, 3, 4, 5. Really, after I've gone past 4, we're done. But 1 plus 6k, you get 7, 13, 19. Here's the good one. 24 plus 1 is 25. So I think we should be okay. So we'll just work that out. So k equals 4. A is 44. 1 plus 6k is 25. So B is 1 plus root 25. B is 6. That would add up to 50. Let's just make sure that the original equation worked out. So that was what I had it on the other page. B times B minus 2 equals 6k. Well, this has got to work out because it's what I rearranged, but we'll just double check. 6 times 6 minus 2 is equal to 6 times k, and that's going to be 6 times 4 is equal to 6 times 4. So 44 plus 6, 50. Hurrah! We know the answer is going to be 50 here at the end, which will be E. And I can already see with question 25, we got these cones and this sphere. I'm not going to have enough space down here, so we're going to flip the page, and we will move on to our last question, question 25. As usual, thank you guys so much for watching, and I will see you for question 25 as we finish off the 2006 Fermat paper in the next video.